Okay, guys, let's go back a little bit. Uh, we gave you this kind of problem before. We did a linear regression. Uh, Here's the Super Bowl ticket prices going back to 1969 up through 2008. And these were actual prices. I actually plucked these off the internet. Here's the actual prices back here. So just to let you know they're valid. Okay. So so here I did is I just gave you some table of values. We did this before, problems like this in class where I said, okay, let's find the line of best fit, and it ended up being not a very good fit at all. So let's go back and just illustrate that for you back here. So here I did. I just put in these values, okay, for these years, with 1969 being year zero, okay, and then here are the values. The C1 is the year, C2 is the price, and in the last year the price was $700. Okay, so we're using this for predictive purposes. Okay, so how did we approach that? Remember, we did F5, and then we chose in this. Let's go back and do the linear regression again, just to show you how terrible a fit that was. Okay. And then, of course, we did the C1, C2 here, okay? And, of course, I had to toggle that off. Then C1, and then C2, and we'll store that regression formula in Y1, okay? And we'll go back and take a look at it. Okay, there's the line in the form y equals ax plus b, and we're taking that line. We're going to take a look at what that looked like as a graph. So go back to the graph. Okay, there's the data in the blocks. There's the line. It's a terrible fit. There's no sense um, in even entertaining this as a possible model. Okay, so so let's go back to our data. Okay, uh, go back to our data matrix, open up our data, and let's try another regression. Okay, so we're keeping the same data, F5 this time. We're going to try an exponential regression. An exponential regression will be option 4 here. Okay, so we're taking the exponential regression this time, and so that would be again, C1 is our effectively our X values. That's the years, okay, and C2 is our price values. Okay, so that's C2, and uh, keeping the same data, and what we'll do is we'll just put this regression formula in Y2 for comparative sake, okay? So here we go. We get the regression formula. The regression formula is given to us as an exponential expression. Y equals A times B to the power X. That's exponential. A times B to the power X, saying that A is 1129 and B is 1.11. Okay, so we've entered that formula into Y2. Okay, that formula is in Y2. Show you that. There's the Y2 formula. There it is, written exponentially. But the truth the uh, is in the actual graph. So let's go and look at the graph. There's our data. There's the exponential regression by linear. Here comes our exponential regression. Look at that. It's a beautiful fit. Beautiful fit. Beautiful fit. Financial things grow exponentially. There's a beautiful representation of an actual life situation with an exponential regression. This could be used for predictive purposes. Okay, according to this predictive purposes, our year uh, our year 2009 uh, should be our 30th year, okay, and we can use that for predictive purposes, okay. 2009 being so yeah, that's our 40th year, okay. So we can go and then go into our table set and do a ask option. Okay, uh, so we can look at that now and see what happens. Okay, we'll go to our table set again. I didn't set that. Set this to ask. Okay, and let's look at our table values. Okay, take a look at the table. Take a look at the table. Go to the home screen rather. Go and look at the table and see what we're looking at. Okay, so we found that let's see, 99 was the 30th year. So in the 30th year, the difference here in the pricing will be significant, I'm sure. Okay, so let's key that in. 30th year by our linear model is $345. The exponential has it going a little lower. Okay, 2008 was our 39th year. Okay, in our 39th year, uh, the actual the pricing by the linear model was 480, and by the exponential model was 796. If we want to look at that's 2008. So you kick that up another 6 years. Okay, that's 2000. Uh, another 6 years, of course, would be 2014. So that would be our 45th year, and the pricing you should expect to pay at that is $1,500 for that ticket, base ticket, to sit up in the nosebleed section. Okay, that's pretty much. I would think that's pretty much in line with what base pricing has gotten. That's not what you're going to get them on StubHub for, but that might be what they're going to price them at. Okay, so there you go. Beautiful application with a beautiful graph, courtesy of exponential regression of this Super Bowl ticket pricing. Okay, mapping out a real life situation to a mathematical model defined by an exponential equation for a very good fit, as shown here, which is in this case 11.29 times 1.15 to the power x. Okay, exponential regression. Most everything that grows is going to grow by some kind of exponential function. Okay, there you have it.